All right, so this is a recap of basically what you've done so far this 6 weeks. Yeah, and it's got some of the harder questions. Now, there'll be some easier questions on your upcoming test, but this is the gist of it. So we have Dullville decaying at a rate of 12% per decade because it's dull. You're supposed to write a model, and since I see decay, I'm going to be using the formula for decay, 1 minus r to the t. Now, because it's per decade, it'll be per decade, okay? So after some time passes, the population of Dullville is its principal, which is actually down here, 1,000 times 1 minus 0.12 to the t over 10, because there's 10 years in a decade. And you should clean that up. You shouldn't just leave that as 1 minus 0.12. I've complained about that for quite some time now. So the amount after time passes is 1,000 times 0.88 to the t over a 10. Converting into a yearly, I think when I'm making this video, I think about 2/3 of you have figured this out by now. It's gotten better. Still a lot of room to get there. We're going to move the 1/10 inside. We're going to leave the t on the outside. And then we're going to pull up a TI-84, and we're going to push buttons. All you got to do is just try and do it. It's not a hard skill. So what we're doing here is we're taking the 12th root of 8,800. So we're asking our calculator, what number times itself 12 times generates 0.88? And it's 0.9894. Roughly 0.9894. So after some time passes, we are the principal of 1,000 times, done forgot, I think it's 0.9894, to a singular t. And now it is a yearly model, and it is going to allow me to do part 3, which is why I keep asking you to convert to a yearly model to figure out the decay rate. So these two pieces are in the same exact spot of the formula. So 1 minus r must equal 0.9894 or vice versa. And then we just do a little bit of shifting. Shift the r over. Shift that guy over there. 1 minus 0.9894 is equal to r. We do the subtraction. If we're going to be pushing buttons or whatever. But if you do the subtraction, the calculator is going to tell you 0.0106. Took me a minute there. I'm tired. 0.0106 or 1.06% per year or per annum. Part 4, if the current population of Dullville is 1,000 Dullvillians, when will there be 2 dull people left? So we're just going to take that 1,000 and we're going to put it, evidently Milbrath needs to wake up today. We're going to take this 2, we're going to put it right there. That's the one I wrote earlier. So 2 equals 1,000 times 0.88 to the t over 10. And I'm going to do this one by and large by hand. I am. So I'm going to divide out my 1,000. So 2 over 1,000 is 1/500th. That would be equal to 0.88 to the t over 10. Now I'm going to ln both sides. The ln of 1/500th is the natural log of 0.88 to the t over 10. I've got a property that says I can shift exponents to the front. So the natural log of 1/500th is t over 10 times the natural log of 8,800ths. All right, so 2 steps and I'm done. I'm going to clear this 10 through multiplication, cancellation on the right. And I'm going to clear that multiplication through division. If you get good at logarithms, like I'm showing all the steps. I mean, I don't do all the steps anymore. I mean, I do them, but I have to sit here and write it all out anymore. If you get really good at working with logarithms, you're going to be faster than going to y equals. You will be, but that's a skill I hope that you guys get to. Anywho, 486.149 years. One 491. There you go. You go buying a brand new John Deere X9 1100 combine for $749,000. John Deere's finance subsidiary has you down for a 7-year loan at 4.9% compounded monthly. What will your monthly payment be? It's going to be a lot. All right, so we're going to use compound interest because we talked about this. The amount of FTO after time is the principal of 749. Oh, I need to write down the formula because y'all probably forgot. It is the principal times 1 plus R over N, rooftop to the NT. So we've got a 7-year loan. The amount in 7 years shall be 749,000. 1 plus the rate, 0.049, compounded monthly, N is 12, with an exponent of 12 times T, 7 years. And it's going to be a bunch of money. 749,000, 1 plus 0.049, sitting pretty over at 12. And if you don't know what 7 times 12 is, the TI-84 won't judge you, but you should know it's 84. It's over $1 million. So 1,054,730, 1,054,730, and then a few pennies. 53 cents. Now, to figure out my monthly payment, 7 years is 7 times 12, 84 months. We'll divide by 84. Now, the truth is, John Deere does not do monthly payments. You make one payment per year. $12,556.32. At least you do when you're talking about the big equipment. That's how you do it. You pay one time per year. So $12,556.32. And again, John Deere doesn't do monthly payments. They do one payment per year. You got to make it. Look at the interest cost on that. Almost over $300,000 in interest. That's what it cost in interest, $300,000, almost half the price of the combine. Suppose a cancerous growth grows at 6% per month continuously. If the growth currently has a mass of 5 grams, how long will it take the mass to reach 10 grams? Okay, so I saw the word continuous. My formula is to use PE to the RT. My principal for this cancerous tumor is 5. E is just a number. R is 0.06, and T is unknown. The goal, however, is to get to 10. And again, I'm going to do most of these notes by hand. Divide out the 5. That'll give me a 2 equal to e to the 0.06t. And lots of ways you can do this one. You can do log as bay. You can ln both sides. Doesn't really matter. I'm a big fan of the ln technique. The natural log of 2 is equal to the natural log of e to the 0.06t. Exponents go out front. And what we'd have to do is we have to memorize that the natural log of e is 1. So we just kind of strike it out in this situation. We divide by 0.06, and then we go and we push some buttons. Natural log of 2 divided by 0.06, 11.55 months, because it was per month. See that per month right there? So the time is about 11.55 months. Cancer's bad stuff. It got my mama when I was a kid. Solve using change of base and your TI-84. Change of base is something that I wish everybody would get. I think we're probably at around 70% when I'm making this video. Log base b of a can be rewritten as log of a over log of b, or ln of a over ln of b. Or you can choose a base, which we don't do too often. That'd be a little c, log base c if I'm chosen b. We do one of these two because those are the ones that exist on our TI-84. That's why we do them. 10 makes sense. We're a 10-based counting system. E is a natural number. There's more to E than you guys will probably ever know. So anyways, I like ln. This would be the ln of 7x minus 2, sitting pretty over the ln of 2, and then plus 3. This guy would be the ln of 3x plus 1, sitting over the ln of a 7, and then minus 2, and then I go to my trusty TI-84. Safest way to do this is to go to math, num, n over d. You can tell I'm old school because I'm just typing. Back in my day, we didn't have this feature. All right, so ln 3x plus 1 divided by ln 7. And make sure that you put the actual numbers outside of the fraction. That is where a lot of kids are messing up. They're not putting their digits in the right place. Zoom 6. Let's see what this one looks like. I think this one's pretty nice. I don't think it's like trying to trick you or anything. Oh, it is trying to trick you. I'm wrong. So do remember that TI-84s do not graph logarithms properly. This is supposed to fall forever, as is that guy. So there is an answer. Second trace. Second trace. There we go. 5 for intersect. And just press that right arrow till you see your cursor, and then press it one more time for good measure. Press enter, enter, enter. And it's going to find the intersection. 0.2913. And we had something like this. Passes through. All right, what yearly rate of interest is required for an investment to triple in 5 years? So this one really bothers kids when I ask questions like this. They're like, well, what did you invest? You invest whatever you want. The easiest thing to invest, it is easy to work with a principal of $1. It's the easiest thing you can do. All right, it is. So our principal is $1. We're going to triple. So the amount after time is going to be $3. So let's plug this in. Now it talks about yearly rate of interest. Your formula is going to be not compound interest, just growth, because it is based on singular events like a month or a day or a year. I invest $1 because it's easy to invest $1. I do not know the rate of interest, but I do know that it takes 3 years, and I know that the desired outcome is a 3. And this is actually a really, really easy problem. Like, it's ridiculously easy. It's old, actually. We have 3 equals 1 plus r cubed. The opposite of cubing is to take cubic roots. So 1 plus r is the cubic root of 3. And I'm just going to take away 1. I'm going to rewrite that as 3 to the 1/3 because that's how we do it. We do power over root, old stuff. And then I'm going to go to my trusty TI-84 and I'm going to push buttons. As I have no idea what the cubic root of 3 is. There you go, 0.4422. Or 44.22%. What would the monthly rate have been? Well, there's a couple ways of doing this. There really are. The thing that might make most sense to y'all, and I'll show you both ways, is instead of having a 3 here, having a 36. Now, why would Milbrath put a 36 in there? Because 3 years, 3 times 12, 36 months. And then what we would do is we would take the 1/36th power of both sides, and we'd still subtract 1. That's one way of doing it. So it's 3 to the 1/36th, and then take away 1. So the 36th root of 3. 0.0309, actually that's 0.0310, or 3.10%. Now another thing you can do, and it's actually a little bit harder this way, is you have to go back up to this. You have to think about what 1 plus r is. And 1 plus r is going to be 1.4422. And that was kind of our yearly growth factor. That's what this was. You take the 1/12th power of that because you're going from yearly growth factor to monthly growth factor. So we're going to do 1 plus that. And then we're going to take that and raise it to the 1/12th power. And we should get the same exact number. Hopefully you see it, how they line up. There's your 3.10%. So 2 ways of doing it. I think the technique or the approach that I used here makes more sense to people than the latter one that I tried to use. But I don't know. You do you. Carbon-14 has a half-life of 5,600 years. What is the yearly decay rate? So let's see here. Our formula for half-life is the principal times 1/2 to the T over HL. And I don't have to have a principal, nor do I have to have anything else. I just have to know how to manipulate this. So I'm going to take my 1 over 5,600 and I'm going to move it to the interior like I've done so many times. I've done it a whole bunch. Have you? And I'm going to get this long decimal, 0.99. I'm going to write it all down too. 0.999876. Two, 3, 1, 4. And you need to understand first off that half-life is decay. So this lines up with the decay portion of the formula. So these two things line up. That means they are equal. 0.9998762,314 is equal to 1 minus r. And then we just shift things around. That's what we do. But anyways, we take that thing away from 1 is the gist of it. And there she is in scientific notation. That is 1.237686 times 10 to the -4th power. I think that was a -4. It was, which means that I move the decimal 4 places forward. I'm going to have 3 zeros leading. And this is what it looks like for significant digits. If I move the decimal as a percentage, I get 0.01237%. If you can do that, you can do any of these decay ones. Skeletal remains of an unknown species are found. They contain 1 times 10 to the -12th of a percent of the carbon-14 of what all currently living species contain. So, if you want to see this as a decimal, that is 0.00. It's going to have 11 zeros before that one. 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, and then a 1%. So this is what happens after time. when the thing died, it had 100% of its carbon-14. And carbon-14 is one of these known half-life things. So 1/2 T over 5,600. Now, how old is the specimen? I'm actually going to switch over to Y1, Y2 right now because I'm burning through a lot of your time. There'll be times on your test where you can't use Y1, Y2, and there'll be times on your test where you can. So let's see, we have 4, 8, 10. Let's count these. 4, 8. Lost my place. 4, 8, 11. Cool. I'm going to do a Zoom 6 even though it's useless. And I have no idea how old this thing is. I am going to go out 1,000,000 years. I feel like 1,000,000 years will probably cover it. So I'm going to change my X max to be 1,000,000. That looks like 1,000,000. So second trace 5 after I played with my window. And you can see your line there, your 0.0001. Oh yeah, it happened. It happened right there. Well, it's happening somewhere in here. Second trace 5. Enter, enter, enter. So there's your answer. The skeletal remains are 260,439 years old. 260,439. That is if you believe it's true. All right, graphing. That's always fun. We have a right 3, and we have an up 2. This is your horizontal asymptote. It is at y equals 2. Make my little table here. Since I went right 3, my table starts at 3, and I just add 1 to 4. If I plug a 3 in, 2 times a 3 to the 3 minus 3 added 2 is 2 times 3 to the 0 plus a 2. Anything to the 0 power is 1. So 2 times 1 is 2, add 2, we get a 4. If I plug a 4 in, I'll have 4 minus 3, which is 1. So 3 to the first is 3 times 2 is 6, add 2 is 8. So I contain 3, 4, and I contain 4, 8, which is sadly not on my little grid. Now you cannot cross a horizontal asymptote. There she is. Easy peasy lemon squeezy. Domain is to run left and right forever. The range, the closest it gets to, the lowest y value it gets to is 2, and then it rises forever. Then we have ourselves a logarithm, because you got to graph a logarithm. You do. Let's see here. By the way, the domain for this thing is going to be 4 to infinity. Because this is a right 4, which is my vertical asymptote, and it's at x equals 4. Remember those mom quizzes we used to take? X equals a constant vertical line. The domain for any logarithm is negative infinity to infinity. It doesn't matter what it is, that's what its domain is going to be. Certain things are just set in stone. And we need to be making a table. And the table on the logarithms was kind of hard. The deal was, it's easy to take log of 1 because it's going to be 0. It's also easy to take log base b of b because it's going to be 1. So if there was a 1 in there, x would have to be 5 because 5 minus 4 is 1. The base is 3. For there to be a 3 in there, x has to be 7. And these are the numbers I'm going to plug in. So I'm going to do some plugging in. A log base 3 of 5 minus 4 add 5 is a log base 3 of 1 plus 5. And log of 1 is always 0. So 0 plus 5 is 5. All right, plug in a 7. Log base 3 of 7 minus 4 add 5 is log base 3 of 3 plus 5. Log base 3 of 3, if the bases match, you get a 1. And 1 plus 5 is a 6. These are my 2 points. Logarithms look like the letter R, don't forget that. So to the right 5 and up 5, and to the right 7 and up 6, then I just draw myself an R. Logarithms are pirates' favorite function because they go R. Boy, that was lame, wasn't it? Yeah, it was. All right, we got inverses and some other stuff. I'm starting to hear some kids. Close my door. All right, first step in writing an inverse is that we swap x and y. I would say 80% of y'all have these down. And then we resolve for y, and then we just use notation. So we're going to get the f out of that thing because it was y, and it becomes x. And there's an x, and she's going to become y. And then we're going to start isolation. It's just isolation. X minus 2 is twice log base 3 of y minus 4, because I did the easy stuff first. Still one more easy thing to do, and that's to divide by 2. All right, now we're going to do something old. We're going to do log is bay. Exponentials and logarithms are inverses of each other. Log is bay is equivalent to b to the e equal to a. So base, argument, and then all of this guy is an exponent. So we're going to have a base of 3. Our exponent is all of x minus 2 over 2. And it's going to equal y minus 4. One little step in isolation. Add 4 to both sides. And that is the inverse of f of x. Next one ain't going to be hardly any harder. Get the g out on this one. We see an x, we make it a y. Do easy things first. We're going to add 7 because that's easy to do. We're going to divide by 3 because that's also easy to do, and we're also playing the isolation game. And now we're going to do log is bay. Bases have exponents, which means that this guy must be my argument. So I'm going to have a log whose base is e. Its argument is this ugly thing, x plus 7 over 3, and it equals 4y minus 1. And I got 2 isolation steps. I need to add 1 to both sides. Do remember that log base e is ln. We're going to counteract subtraction before we counteract multiplication. Counteract multiplication through division. And there she is, because y is just isolated. All right, almost done, because I'm sure you're tired of watching this. We got into condensing, expanding, and then an easy one. So we're going to condense. Properties here that you need to know is that log of a, b is log a plus log b. And log of a over b is log a minus log b. And you also need to know that log a to the r is r log a. Those are your properties. Use that last one first. These things need to be moved. So I'm going to have an x plus 2 squared on this one. Here, this one I'm going to do some work with. I have 16 to the 1/2. You're expected to know that the 1/2 power is the square root. So this is going to get reduced down to log of 4, which I can't do anything with. All right, so multiplication gets broken apart through addition. So anything that's being added together is being multiplied inside the singular log. So I've got an x plus a 2 that is squared times a 4, which I should put in front. Division is broken apart through subtraction, so I'm sitting over z cubed. And I really do need to put the number out front. 4 times x plus 2 quantity squared, sitting pretty over z cubed. 2 to go. We got an expansion. So there are 1, 2, 3, 4, 5 distinct things in this logarithm. So sadly, I have to write log base 3 5 times. First one contains root 81. Next one contains z cubed. And these two were in the numerator, so they were positive. These three are in the denominator, so they are all negative, at least for now they are. This one has a 4 in it, this one has a y squared in it, and this one has an x to the negative 5. Something's going to happen to that one. Root 81, I'm going to take a close look at log base 3 root 81. Root 81 is 9. This logarithm says what power of 3 creates a 9, and the answer to that is a 2. So that becomes a 2. Exponents to the front plus 3 log base 3's of z minus log base 3 of 4, which I'm not touching because I have no idea what power of 3 creates a 4, minus 2 log base 3's of y, and a negative times a negative is a positive, so plus 5 log base 3's of x. And that is the complete expansion of that logarithm. I know you loved that. I know you did. And the last one, the easy peasy problem. For f of x is 7 log bases of 6 of 7x plus 63. Take away 12. What is the domain of this thing? You have to remember a really, really simple rule. For a logarithm with an argument, the argument is bigger than 0. So 7x plus 63 is bigger than 0. 7x is bigger than negative 63 because we're counteracting addition. And now we're going to divide both sides by 7, and I'm pretty sure that's going to be negative 9. X is greater than negative 9. So if you like your set builder notation, which only Maddie does, that's what it looks like. If you like your interval notation, which some of you will all at least tolerate, negative 9 to infinity. All right, what is the range of f of x? You don't have to graph. This is your vertical shift. Oh, actually, it's a logarithm. The range of a logarithm is always negative infinity to infinity because logarithms look like r's. An r falls forever and rises forever. And there you go. That took a little longer than I thought it would, but it was basically a recap of the entire everything we've done for the last 3 weeks. So it should have taken some time.